Hey dear listeners, welcome to today's lesson on statistics. In statistics today we're going to talk about how to calculate mode of grouped data. Mode of grouped data. You know that how to calculate mode of on grouped data is slightly different from calculating mode of grouped data. First and foremost, what is mode? So let's look at mode. Mode is simply what? The set of information with the highest frequency. That means if I have 2, 3, 4, 6, 2, 2, 5, and so on, if I have this set of information and we are told to, this is ungrouped because it's just randomly written. So here, if I want to calculate the mode, what do? I'll simply look at the item or the particular number or the particular one that has the highest frequency that appeared most. So if you look at it, we have 2, we have 2, we have 2. So 2 is our mode. This happens when we're talking about what? Ungrouped data. But for grouped data, it is simply, or it is slightly different. Slightly different because grouped data is arranged in tables, rows and columns. So let's look at how we can calculate mode of grouped data. So for us to calculate mode of grouped data, we have a particular formula we use. The formula is mode is simply L1 plus delta 1 over delta 2 plus delta 1 divided by delta 1 plus delta 2, then all multiplied by C. I will explain what each and every item here is. L1 here simply means, L1 means what? Lower class boundary of the modal class. Lower class boundary of the modal class. I will explain when we draw the table. Then here we have delta 1. Delta 1 simply means what? Difference between the modal frequency and the frequency of the class before it. So difference between the modal frequency and the frequency of the class before it. Then we have delta 2. Delta 2 again is difference between the modal frequency and that after it. Which when we start solving, you will see all these things I'm talking about. Then we have again C. C simply means what? Class size. Okay, so hope you've written down this formula. Let us use it to solve our problems. And I will explain in the process of solving the problems, we will show ourselves what L1, delta 1, delta 2, and C means. Okay, so let's take one simple question from here. So let's look at this question here. It says, calculate the mode of this set of information. Calculate the mode of this, or calculate the mode of this set of information. Of this set of information. See the set of information here. So here we have is the class interval. This is class interval. Here we have the frequency. Okay, so we have 0 to 9. We have 10 to 19. We have 20 to 29. Then we have 30 to 39. Alright, so the frequency here is 5, frequency here is 6, frequency here is 12, the frequency here is 10. Okay, we have another one. Then this is 40 to 49. 40 to 49. Here, the frequency here is 8. Good. So we're told to calculate the mode of this set of information. If you recall the formula that I gave out, which is what? That our mode is L1 plus what? Delta 1 all divided by delta 1 plus delta 2 all multiplied by C. So here, let's look at how we can calculate this. Let's create our columns. Let's create our columns and see how many columns we will need for this. So the first we have is the column for class interval. Class interval, which our intervals we know is 0 to 9, 10 to 19, 20 to 29, 30 to 39, and then 40 to 49. Okay, then from here, if you like, we can go ahead and look at our class boundary. How you fill it up is of little consequence here. So we can start after class interval. Let's look at class boundary. Let us talk about class boundary because we are looking at lower class boundary and upper class boundary as far as mode is concerned. So the next one is class boundaries. Class boundaries. So class boundaries, that's the way we calculate class boundaries. You choose a particular standard. If I want to go with standard of 0.5 plus or minus 0.5, or go with the standard of plus or minus 0.3. So here, if I'm going with negative 0.5 as my standard, so it means I'm taking off 0.5 here and adding up back 0.5 here. So if you take off 0.5 from 0, it becomes negative 0.5. Then down to, I'm adding it back, 9.5. I will explain again. You go to the first class interval, remove 0.5 and add back the 0.5 here, so it doesn't look as though you are throwing away anything. So now this one, now the end point here becomes the starting point here. We have 9.5 down to 19.5, then 19.5 down to 29.5, then 29.5 down to 39.5, then 39.5 down to 49.5. So we have generated the column for our class boundary. So the next one is going to be frequency. Frequency, we have 5, we have 6, we have 12, we have 10, and then finally we have 8, which we can draw our line. Then after that, we can go ahead and put cumulative frequency, which we may or we may not use. Okay, now our cumulative frequency, just for the purpose of knowing what cumulative frequency is. Cumulative frequency is simply the addition of frequency down the column. So if you have here the first cumulative frequency is going to give us 5. 5 plus 6 gives you 11. Then we have 5 plus 6 plus 12. So 11 plus 12 gives us 23. Okay, then 23 plus 10 gives you 33. Then 33 plus 8 gives you 41, I think. Yes, so this gives you the column for your cumulative frequency. So let's go ahead now and use this to get our mode. So remember that mode is what? Mode is equal to L1 plus what? Delta 1 divided by delta 1 plus delta 2. Delta 1 plus delta 2. All multiplied by C. Now what is this C? Class size. Class size is simply the difference between two successive lower or upper class intervals. So if I'm taking the difference, it means 10 minus 0 gives you 10. 20 minus 10, it still gives you 10. 30 minus 20, 10. So whichever one you choose, even if you like, you can go with the class boundaries. So here you can say again, 19.5 minus 9.5 will still give you 10. So in this case, our class size, which is C, our C is equal to 10. So if your class size is 10, so let's go ahead now. So it means that our mode will now be L1 is lower class boundary of the modal class. What is our modal class? Our modal class is that class where the highest frequency occurred. Here, which is our highest frequency? 12. So it means that this point here, this from here down to this point here, up to this point, this is our modal class. So this class here is called what? The modal class. So if we are picking it up, this line here is called our modal class. So the modal class is the class that carries what? The highest frequency. So the highest frequency here is 12. So our modal class is this. So it means that this one is the lower class boundary of the modal class. So where is the modal class? The modal class is here. What's the lower class boundary? The lower class boundary is what? 19.5. So it means that L1 is what? 19.5. Then plus delta 1. Delta 1 is the modal frequency. The modal frequency subtracting what? The frequency of the class before it. Remember, I explained it. That means D1 is the modal frequency. The modal frequency here, 12. So the class before it is 6. So it means that D1 is what? 12 minus 6, which is equal to what? 6. All divided by. Then D1 already, which we know is 6. Then plus delta 2 is the difference between the modal frequency and the class. The frequency of the class after it. That means 12 minus 10, which is what? 2. So plus 2. All of them multiplied by 10, because we know that class size is 10. Alright, so it means that our mode now becomes 19.5 plus, we are having now 6 all divided by 8. Okay, then all of them times 10. So what is 6 divided by this will give us 3, this will give you 4. So it now means we have mode will now give us 19.5 plus, this is 3 over 4, this was 0.75. So this is, remember that in BODMAS we are going to multiply this before we subtract. So we are multiplying, if we like, we'll go with 10 times 3 gives you 30 over 4. So we have 30 divided by 4. And what is 30 divided by 4? If we're going to go with using that 30 over 4, let's look at it here. 30 divided by 4. So it will go 30 in 4 times. It will go 15. Let's look at it. Seven times 4 is 28. So it will go 7 times remainder 2. 2 over 4 is 7.5. So we'll have 7.5. So we'll have 19.5 plus 7.5. So, which by the time you calculate, what are you going to get? You have 7 plus this will give you what? 26. So 26 plus half will give you, so our mode is what? 27. So you can see how we calculated our mode for grouped data. So you can go through it and see if we have any complaints. You can look at it, and in our next video we are going to explain and then talk about how to calculate median of grouped data. Alright, so remember to subscribe, and till then, have a nice time and see you again.